This is the very question many philosophers and scientists have been asking lately. Although the question would have been ridiculed decades ago, a different picture is now emerging. The results of experimental and theoretical data have been producing some strange results. Results that do not tell us our world is objectively real, but emerging from something else altogether. And in the rise of the digital age, we are starting to see a correlation between our world and the world of a virtual reality. The very notion that our world is virtual, or dreamlike, is explored by Brian Whitworth. He took the two possibilities, one being the realist hypothesis that our world is physical, exists in and of itself, and needs nothing outside of it to explain it, and the other being the virtual reality hypothesis, that our world exists as a virtual reality, depending on information processing happening outside of space-time. He looked at all the facts we know from experimental data and asked which hypothesis better fits the data. After looking through it all, the conclusion was obvious. The data better fits the idea we are a virtual reality. Our world makes more sense if we look at it as a virtual world, and not an objective one existing independently. He started at the beginning, the Big Bang. This established fact that space-time was created from a single event billions of years ago. Although hypotheticals have been proposed to get around this beginning point, the fact remains, our universe, space-time, began to exist. From the view that our universe is all there is, as an objective independent reality, this makes no sense. How does space-time emerge from nothing? But if we look at the universe as a virtual reality, the Big Bang fits perfectly. Virtual worlds must begin with information influx from nothing. Brian Whitworth says, virtual reality theory fits well with the Big Bang. No virtual reality can have existed forever, since it needs a processor to start up. Every time one starts a computer game or boots up a computer, such a Big Bang occurs. From the perspective of the virtual world itself, the creation is always from nothing. As before the virtual world startup, there was indeed no time or space as defined by that world. Another thing to look at is quantum minima. The fact that things like light are quantized as photons better fits the hypothesis that we are a virtual reality. In digital processing, all events and objects must have a minimal quantity that cannot be reduced anymore, and yet our world has the same effect.
Every computer-generated image, no matter how realistic, breaks down into pixels when you get close enough. You might think this doesn't happen in the real world, but you'd be wrong. In the past century, physicists have discovered that matter really is made of tiny little pixels, fundamental, indivisible particles billions of times smaller than an atom.
Look at the way the universe behaves. It's quantized. It's made of pixels. It's made of individual atoms. Space is quantized. Time is quantized. Energy is quantized. Everything is made of individual pixels, which means the universe has a finite number of components, which means it has a finite number of states, which means it's computable.
And that the true nature of the universe is indeed digital, that we have smallest space, smallest time, and that there's nothing that you cannot compute. And at the moment, there is no evidence against that.
What about the fact that there is a maximum speed, the speed of light? Events in a virtual world must have a maximum rate limited by a finite processor, and our world has a maximum speed. Einstein deduced that nothing travels faster than light from the way the world works, but this does not explain why the world had to be that way. Why cannot an object's speed simply keep increasing? If light is like a classical wave, its speed should depend upon the elasticity and inertia of the medium it travels through. If light travels through the medium of empty space, its speed should depend upon the elasticity and inertia of space. However, how can empty space have properties? Virtual reality theory explains this, but objective reality cannot. There is also how space curving of massive objects and time dilating at high speeds correlates to virtual processing load effects. High matter concentrations in our universe may constitute a high processing demand, so massive objects would slow down the information processing of space-time. In the same way high amounts of data processing in a computer slow the processing speed down. The fact that all quantum objects are identical to each other correlates to digital equivalence, in that in a virtual world, every digital object created by the same code is identical. The same holds true for quantum particles. And these are just a few of the 11 facts Brian Whitworth lists. He concludes by saying, individually, none of the above short points is convincing, but taken together they constitute what a court might call circumstantial evidence, favoring virtual reality against objective reality. When coincidences mount up, they present a plausibility argument, if not a proof. More powerful evidence is provided by cases which a virtual reality theory explains easily, but which objective reality approaches have great difficulty with. And this is only the beginning. In the hunt for a theory of quantum gravity, the theoretical data better fits the idea we are a virtual reality. Both underlying string theory and loop quantum gravity is the holographic principle. The idea of the three-dimensional universe emerges from information processing on a 2D surface.
Maybe the three-dimensional objects, us, everything in the world around us, maybe all of the information in these objects is carried, is smeared around a distant two-dimensional surface that surrounds us, and we're just in some sense a holographic projection of that distant data.
The holographic principle tells us something quite astonishing. It says that our ideas of volume, of the real world in a sense, might be a kind of illusion.
We forget about what space is and what time, and then somehow the information, by thinking about how much information is, what information is doing, then the space-time will, what we call, be emergent. It will come out of just a bunch of zeros and ones.
It should be clear that this whole holographic story is the most radical thing that has happened to our understanding of space, time, matter, since the invention of quantum mechanics and relativity.
Now, someone could always dismiss the theoretical data, but that would be impractical, because it would take away our best chance for a theory rectifying relativity in quantum mechanics. Even so, the experimental data cannot be ignored, and the results of quantum mechanics infers the same implications we see in the holographic principle.
Quantum mechanics means it's possible everything we see could really be produced by lines of code inside a powerful computer.
So we cannot ignore the recent experimental data, like the fact that for objective reality to be true and the world to exist independent of observation, something known as locality would have to follow, which means for objects to interact, they need to be in close proximity. But experiments in the early 80s showed this is not the case. Instant interaction can be seen between two particles that are separated from great distances. This is what we now know as entanglement, and it makes more sense if the world is virtual. In a virtual world, space doesn't limit correlations. All points in a virtual world are equal distance with respect to the source of their simulation. So for example, in computers, all points on a screen are equal distance with respect to the CPU. Processors can ignore screen distance, and the same thing happens in our world. If our universe is a three-dimensional screen, its processing is equal distance to all points in the universe. So the non-local collapse of a quantum wave function could be such an effect. Space seems to be an illusion created by the virtual construct, which is something Einstein came to realize at the end of his lifetime. Hence, it is clear that the space of physics is not, in the last analysis, anything given in nature or independent of human thought. It is a function of our conceptual scheme. Space as conceived by Newton proved to be an illusion. But even more strange than this is what quantum physics tells us about matter. Prior to observation, matter doesn't exist. This was demonstrated in the 1920s by the double-slit experiment. The existence of matter is dependent on observation, and recent experiments have not only reconfirmed this, but have debunked theories in order to avoid the conclusion that the existence of matter is observation dependent. Now, many accept that particles do not exist prior to observation, but they exist in a state of a wave, which then forms into particles upon measurement. But this would be false. As they point out in the quantum enigma, quantum probability is not the probability of where an atom is, it is the objective probability of where you or anybody will find it. The atom wasn't someplace until it was observed to be there, which is what Heisenberg said years ago. The atom or elementary particles themselves are not real. They form a world of potentialities, or possibilities, rather than one of the things or facts. But what does this all mean?
These basic rules of quantum mechanics apply to all tiny subatomic particles. When we look at them, they are just dots. When we look away, they lose their physical form.
A different way of looking at that is to say, well, how parallel is this behavior with what I see in my PlayStation 3 when I'm playing a video game? In a PlayStation 3, an example of that is SimCity. It's an enormous city. I can navigate my way through every bit of it because the PlayStation, the video game, gives me the frame that I need when I'm looking there. If I look somewhere else, it'll create that frame. Well, oddly enough, the universe behaves that way in reality. The universe gives you what you're looking at when you're looking at it. When you're not looking at it, it's not necessarily there.
Our world is pixelated and only assumes definite form when observed, the very same way our computer simulations behave.
The conclusion is inescapable. The universe behaves as a virtual reality. In light of the evidence, this is why this question is now taken seriously by experts. Which brings us to the next question.
The more interesting aspect to that question is, who's the programmer and where's the computer?
If the universe is a simulation, who is the simulator? Should we take the view of Nick Bostrom, that we are being simulated by future humans as an ancestor simulation? Well, the problem with this theory is it really doesn't answer the question. If we are being simulated by future humans, then their world would have to have the same features as ours and be based on qubits, and this would imply they are also a simulation. Using Leibniz's law and discernibility of identicals, it would have to follow that they are also a simulation, if they have the exact same world as ours, just further in the future. If the properties of our world entail that we are a virtual reality, then a world identical to ours would have the same implications, but if their world needs outside processing, they would also need a simulator. And if they are also being simulated by a future civilization, then the cycle continues, and it is nothing more than an infinite regress. Borstrom admits this and says, "We would have to suspect that the post-humans running our simulation are themselves simulated beings, and their creators in turn may also be simulated beings. Reality may thus contain many levels." So this amounts to nothing more than an infinite regress. But what if one of the higher levels is not a quantum world, but an actual objective world based on classical physics? Well, this solution creates more problems than it solves. For a quantum world like ours to be simulated in a classical world, all of the qubits would have to be unpacked into classical bits, and this would result in a classical computer hard drive bigger than that which is being simulated, so a computer bigger than the universe itself, which would be absurd to postulate and impossible to build, which leaves us with a different alternative. The universe is being simulated in a mind.
Could what we think is the universe be some sort of vault of heaven rather than a real thing?
Given the problems that result from being simulated on a computer, one can find a much simpler explanation that the universe is being simulated in a mind. This would solve many problems of being simulated on a computer, because a mind has elements of integrated information states and also processes information, and the physics in a dream environment would emerge from information processing and therefore look identical to the conditions of our world as we described earlier. So a dream environment just emerges from Platonic information in a mind, which is essentially the same type of physics we see in a generic information construct, such as the illusion of space and matter and the elements which make it finite and computable. Even more important, a mind, different from the brain in a computer, is an immaterial substance and doesn't require matter to exist. In fact, interestingly enough, matter seems to need mind, since this is what quantum mechanics tells us. Mind is necessary to collapse a wave function for matter to exist.
So recent experiments led by the group at the University of Vienna, Austria, provide the most compelling evidence yet that there is no objective reality beyond what we observe. So it's really the observation that creates the reality. And what they found is that Leggett's inequality is violated as well as Bell's. Even if you allow for instantaneous influences, quantum measurements do not fit with the idea of an objective reality.
So a mind, unlike a computer, doesn't require the existence of particles to be built upon. So given the options, the most likely case is the universe is actually being simulated in an immaterial necessary mind.
An all-powerful, all-knowing, super-intelligent being. An entity whose motives are unfathomable.
It's very important for us physicists to not dismiss ideas just because they are weird. Because if we did, we would have already dismissed atoms, black holes, and all sorts of other marvelous things.
But from this deduction, we can then formulate a simple argument. Premise 1. Simulations can only exist in a computer or in a mind. Premise 2. The universe is a simulation. This, of course, comes from the evidence presented earlier. Premise 3. A simulation on a computer still must be simulated in a mind. This would follow from the infinite regress problem if we were being simulated on a computer. To prevent the infinite regress of endless computer simulations, we eventually have to stop postulating higher levels of computers and stop with a simulation existing in a necessary mind. And we would also have to remember the importance of Occam's razor. If we have to inevitably arrive at the conclusion of existing in a mind, then why even postulate intermediate levels of computer simulations, unless it is necessary to do so? And no reason suggests this. And one can also argue that it may not even be possible to simulate conscious beings in a computer, given this hasn't been demonstrated to be possible, and one can argue that consciousness is more complex than just information processing. So Occam's razor shaves these off. But even if one insists on leaving them there, the universe would still exist in a mind anyway. So inevitably, we have to say premise 4. Therefore, the universe is a simulation in a mind. Premise 5. This mind is what we call God. And the conclusion simply follows.
Dreams, they feel real while we're in them, right? It's only when we wake up that we realize something is actually strange.